Assalamualaikum and good evening. Today we're going to talk about 3.4 of the maximum and minimum problem. When do we use this? We're using this when we're trying to search the maximum or the minimum value of a variable. How do we apply it? Okay, first we're going to find the first derivative. Second, from the first derivative, we're going to let it equals to 0. And the final part, we're going to find the second derivative. From the second derivative, we're going to get two possible outcomes. The first one is if it's more than 0. If it's more than 0, then it's going to be the minimum value. But if it's less than 0, then it's going to be the maximum value. Right, that's all from me. Now we're going to head on to the problem solution.
Okay, so after understanding what the topic is about, so we're going to know what to solve in this subtopic. So we have the question here, which is from tutorial 6, question number 4, about our subtopic. And we have three questions, which is express x in terms of y, show that the area S cylinder square is enclosed by the y is equals to 378y minus 12y squared. And lastly, find the maximum area enclosed. So what to solve essentially is for A, we isolate x to find the value of it with the term of y, means x equal to y. And then for B, we use the formula for the area of triangle and rectangle, and then use the x value from A to show that it is equals to 378y minus 12y. And lastly, find the maximum area enclosed, which means we have to find the value of x and y at its maximum value, and it is still equals the parameter is still equals to 200 centimeter. Okay.
So after that, I explain what to find from each question. So now I'll show you how to solve it, starting with question A, which is express x in terms of y. But the first step is to find the information that is given from the question, which is, for this question, they already gave us the perimeter, which is 100 centimeters. So we all know how to find the perimeter, which is by adding all the lines from the shape. And here I already mentioned all the values from each side and arrange it. So what it said, express x in terms of y, which means x is equal to y. So x is on the left hand side and y is on the right hand side. So after you sum all the value, you will get this. This is the simplified version. So in order to get this, you need to replace the position like this. So here we have 23. We can we can subtract 200 with 23, and we can get say 177. And then this 6y, we're gonna take it and put it on the right hand side to get this. So we get x equals to 277 minus 6y, which we can simplify more by put 3 on the right hand side, which we will get 59 minus 2y. X equals to 59 minus 2y. So this is for question A. Alright, now for question B, which will show that the area A centimeter squared enclosed by the wire is 378y minus 12y squared. So what the question wants is to prove that this shape, the area of this shape is this quantity equation. This equation. Alright. First of all, we need to identify the formula for both the area and the formula for the area for both shapes. So for the triangle, the formula is 1/2 times h times b, which is h is the height and b is the base. And for the rectangle is long times with y. We can find the values from this shape, which is first of all, we need to do the equation for the area, which is 1/2 hb plus lw for both shapes, and then substitute the value into the formulas. So for the triangle, 1/2 times x times 6y plus, for the rectangle, 3y times with x plus 8. So simplify everything, and you will get 6xy plus 24y. And then the x from earlier, which is 59 minus 2y, it is from question A, because we express x times of y, so we have the x. So substitute the value into the formula, simplify it again, and 354y plus 24y, we will get 378. This already simplified, so we have proven that the equation is the same from the question. So that is all for question B. Right, last but not least, question C, which is find the maximum area enclosed. So here we have 3 steps to find this, to find the maximum area. The first step is, first we need to find the first derivative. The area given earlier, 378y minus 12y squared. So we need to differentiate the equation where we will get 378 minus 24y. So the reason we want to find the first derivative is we need to find the value of y. Then in order to find it, we need to let dA per dy equals to 0. So as you can see here, simplify everything and
to a certain point.
To put it simply, just bring 378 to the side. That is 0, so the value, so you get negative 378 equals to negative 34y, and bring negative 34y, divide each of them, negative, and you get negative, divide with negative, you will get a positive answer. So y is 15.75 centimeter. So the next step is to find the second derivative, to do a second derivative test. So you will get the first derivative, and then you differentiate it again, and you will get negative 54. You cannot do anything anymore with this because it is already simplified. So negative 54 is lesser than 0, so y. So for the second step, the reason is to prove that y is either maximum or a minimum value. So after all of this, so y 15, so y is maximum value. Okay. After that, the last step which is step 3, which is to find the maximum area. So we already have y. Just substitute it to the area equation, this one, and we will get 976.75 centimeters squared.
Hello, Assalamualaikum. So I will be tell you guys about the conclusion of our subtopic today, 3.4 of the maximum and minimum problem. So as you can see just now, my friend already explained to you how to use dy of dx, and or you can say f prime x, and how to let dy dx equals to 0 and how we apply it. Also how we use this equation to prove that the equation is right. So I think that's all from this subtopic, and that will be our conclusion. Thank you.